Okay, this is a test review for Exam 1, Math 1060. Starting with question 1, we have to convert between degrees and radians. So what we talked about in class, converting between degrees and radians or vice versa requires a conversion factor. So if I'm going to try to cancel out degrees here, then I need to have degrees in the denominator. So 180 degrees is the same as pi radians. So now I can cancel out the degree unit of measure. We have 160 pi over 180. And then if you simplify that fraction and keep it in terms of pi, you're going to have 16 pi over 18. Keep simplifying that down. We're going to have 8 pi over 9. Now, number 2 is already in radians, so we're going to want to go into degrees. And so this time I'm going to have pi radians in the denominator and 180 degrees in the numerator. Now, pi cancels out. And then we just simplify numerically here. 11 times 180 divided by 12. So 11 times 180 divided by 12. 165. Question 3, coterminal angle. If you recall, a coterminal angle, for example, if I had this angle here, 45 degrees, if I measured all the way around the circle, 360 degrees plus another 45, which would be 405, that would be coterminal. So coterminal angles share the same terminal side, and the way you find it is just adding or subtracting 360 degrees. So if I add 360 degrees onto that, that would give me a positive coterminal angle. So 360 minus 306 is 54 degrees. Now, another way to find coterminal is to subtract 360. So if I subtract 360 from that, I'm going to get negative 666 degrees. So the thing to keep in mind here, coterminal, if I graphed negative 306 degrees, 54 degrees, or negative 666 degrees, it's the exact same angle. It just depends on how many times around the circle you're going, whether you're going counterclockwise for the positive direction or clockwise for the negative direction. But all three of those are the same angle, or measures the same angle. Now, for question 4, it's the same idea. Now it's in radians rather than degrees. So one way you could do this is you can convert this into degrees, like we did on question 2, multiply it by 180 over pi, and then 5 times 180 divided by 2 would be 450. Let's see. And then you could add and subtract 360, or because it just wants a positive and a negative coterminal angle. If I subtracted 360 from this, it's going to give me 90 degrees. So 90 degrees is a coterminal angle. And if I subtracted 360 from that, that'd be negative 270. Now the thing is though, since we started in radians, our answers need to be given in radians. So even though 90 degrees and negative 270 degrees are coterminal angles, you'd want to convert both of those into radians before your final answer. Now let me just suggest an alternative if you don't want to have to mess with going from degrees to radians, back to degrees and vice versa. To find a coterminal angle, you add or subtract 360 degrees, but if you're in radians, that's just 2 pi radians. So 5 pi over 2, if I want to subtract 2 pi from that, that's the same as subtracting 360. It's the same as subtracting a full revolution of a circle. And it's 2 pi over 1. So if I wanted to subtract, I could just keep it in radians and subtract 2 pi over 1 is the same thing as 4 pi over 2 if I want to get a common denominator. So 5 pi over 2 minus 4 pi over 2 is pi over 2. And then if I want to subtract one more circle, because that's our positive coterminal angle right there, if I wanted to subtract to get my negative, I would take pi over 2 and subtract another circle, which is 2 pi, but I'm going to call that 4 pi over 2. That's going to give me negative 3 pi over 2. So pi over 2 and negative 3 pi over 2. Now question 5 and 6. The length of the arc is radius times theta, and the area of the sector is 1/2 r squared theta. Those are the two formulas. We have to make sure that the angle is in radians, because theta has to be in radians. This one is for question 5. So for question 5, the arc length is just the radius, which is 6. Multiplied by the measure of the angle. So this is 30 pi over 4, which is 15 pi over 2 yards. That's the distance of this arc right here. 15 pi over 2 yards. Now the area of the sector would be the area of this piece of that circle. That would be that sector. The formula is one half times the radius squared times the angle. So 6 squared is 36. Half of 36 is 18. So this is 18 times 5 pi over 4. Then 18 times 5 is 90. So then we have 90 pi over 4, which is 45 pi over 2 yards squared. That would be the area. Pretty much the same thing with question 6, using the formula. So arc length is radius times the angle and then the area of the sector is 1/2 radius squared times the angle. So 19 squared, 361. So that's not going to divide evenly. So we have 361 halves times pi over 3 equals 361 pi over 6 square yards. For question 7 and 8, we need to find a value of a trig function. So you need to recall the definition of secant. Secant of an angle, secant is the reciprocal of cosine. Cosine is adjacent over hypotenuse. So then secant will be hypotenuse over adjacent. And according to where our angle theta is, this is the adjacent side, this is the opposite side, and that's the hypotenuse. So we're missing the hypotenuse. We need to use Pythagorean Theorem here to find the length of the hypotenuse. So 6 squared plus 2 squared equals the hypotenuse squared. So C equals square root of 40, which simplifies to square roots of 10. So the secant will be the hypotenuse divided by the adjacent. So simplify that and get the square root of 10 over 3. The cosecant, number 8, cosecant is the reciprocal of sine. Sine is opposite over hypotenuse, so cosecant will be hypotenuse over opposite. And where our angle theta is in this triangle, this would be the opposite length. This is the hypotenuse, and that's the adjacent. So the opposite length I'm going to call A, since we don't know what it is. So we have A squared plus 9 squared equals 15 squared. And then do Pythagorean Theorem, 225 minus 81, 144. So then square root on both sides and get the opposite length there equals 12. So then the cosecant of the angle is hypotenuse length over opposite length. Divide both of those by 3. Okay, cotangent, so we need to find the secant given the cotangent. Now the cotangent is adjacent over opposite. So the adjacent length is square root of 3 and the opposite length is 1. So what I'd suggest is just drawing a general right triangle and choosing one of the angles for theta. I'm going to choose it down there. And according to the information given here, the adjacent length is the square root of 3 and the opposite length is 1. And then we're supposed to find the secant. And remember, the secant is hypotenuse over adjacent, so we don't know the hypotenuse. So we need to find that using Pythagorean Theorem. 1 squared plus square root of 3 squared equals c squared. So 1 plus 3 equals c squared, which means c squared equals 4. So c equals 2. And then, by definition, the secant of an angle is hypotenuse over adjacent. And you go back to your triangle that you've drawn here and the adjacent length to that angle. So the hypotenuse is 2 and the adjacent length is square root of 3. Now, same given information that cotangent is adjacent over opposite. So the adjacent length is 2 square roots of 22 and the opposite length is 9. So again, you can just draw a random right triangle and choose where to place theta. Again, I'm going to put it down there in the bottom right corner. So the adjacent length will be 2 square roots of 22 and the opposite length will be 9. So using that information, we need to find the hypotenuse, which is c. So 9 squared plus 2 square roots of 22 squared equals c squared. 9 squared is 81. 2 square roots of 22 would be 4 times 22, which is 88. 81 plus 88, 169. And if you square root 169, you get 13. And then cosecant of an angle is hypotenuse over opposite. Okay, question 11. Cosecant and sine and cosine and tangent were given alternate definitions rather than on a right triangle. We were given definitions on a circle relating to x, y, and r. Cosecant of theta be r divided by y. Where r is the radius of the circle, x and y will be coordinate location of the point on the circle. And x, y, and r are related by the Pythagorean theorem. X squared plus y squared equals r squared. So in order to find r for this one, we're going to have to do Pythagorean theorem. Negative 2 squared is 4. 4 plus 4 is 8. So r equals the square root of 8, which is 2 square roots of 2. So cosecant of theta would be the r value divided by the y value, so negative square root of 2. The definition of sine is the reciprocal of cosecant, so it's y over r. So again, we need to find the value of r using this Pythagorean theorem. Negative 3 squared is 9, square root of 7 squared is 7. So r equals 4. So then the sine would be the y value divided by the value of r. Okay, 13 through 18 from section 2.3, evaluating the exact value of a trigonometric function. The way this was presented in 2.3 was to use special triangles 30, 45, 60, the 30, 60, 90, or the 45, 45, 90 triangles, reference angles. So cosine of 45, or rather cosine of negative 45, negative 45 degrees is down here in the fourth quadrant. And then you always want to draw your reference angle to the x-axis. So this reference angle here is a 45-degree reference angle. So what we need to consider is the 45, 45, 90, which has side lengths of 1, 1, square root of 2, and then cosine of the reference angle is the adjacent length divided by the hypotenuse. And then you need to remember that in quadrant 4, the cosine is positive. And since we're dealing with cosine, the cosine of the original angle and the cosine of the reference angle is going to have the exact same value, both positive. So the answer is 1 over square root of 2. I'm okay if you leave it like this in this form. If you want to rationalize the denominator like you've been taught, then you could multiply it by the square root of 2 over the square root of 2 and write this answer as the square root of 2 over 2. Question 14, 2 pi over 3. The angle measure of 2 pi over 3 is in radians. If it's easier for you, you can convert radian measure into degree measure by using the conversion factor 180 over pi and then simplifying. So 3 goes into 180 60 times. 60 times 2 is 120. So this is a 120-degree angle. Which is right there. The reference angle for that would be drawn down here to the x-axis. So that would be 60 degrees. That has a 60-degree reference angle. So what we need to consider then is the 30, 60, 90 triangle. And that has side lengths of 1, 2, square root of 3, 2 being the longest length, so that's got to be the hypotenuse. 1 is the shortest. Square root of 3 goes there. Now, 60 degrees, reference angle. The definition of sine is opposite over hypotenuse. The opposite length of 60 degrees is square root of 3. The hypotenuse is 2, so this is square root of 3 over 2, and then now we have to consider that the angle is in quadrant 2. And if you recall, in quadrant 2, the sine and the cosecant are positive, and so we can maintain a positive value there, square root of 3 over 2, and not make it negative. So the answer to the original question, sine of 2 pi over 3 or sine of 120 degrees, is equal to square root of 3 over 2. Question 15, 19 pi over 4. Again, it may be easier for you to consider the degree measure rather than the radian measure. So multiply it by 1/8 over pi. And then simplify. 19 times 180 divided by 4. So that's 855. Now that's more than a couple of revolutions of a circle. That's quite a, so that's more than 2 turns. So I want to get this down inside of 1 revolution of a circle. So I'm going to subtract 2 revolutions, which is 720. So we get 135. Now this is a coterminal angle, 185 or 155 degrees and 135 degrees. It's a coterminal angle, which means tangent of 855 and tangent of 135 exactly the same, because we're just going around a circle twice. So I'm going to draw the 135 degree angle. This is 135 degrees, which again is the same as 855 degrees. Now we need to consider the reference angle. The reference angle would be this angle drawn to the x-axis, and that's 45 degree angle. So we need to consider the 45, 45, 90 triangle, which has side lengths of 1, 1, square root of 2. So tangent of the reference angle 45 is equal to opposite over adjacent. But since we're dealing with tangent in the second quadrant, only the sine and cosecant stay positive. Everything else is negative. So if the tangent of 45 degrees is positive 1, then the tangent of 135 degrees would be negative 1. So the tangent of 19 pi over 4 is negative 1. Question 16, 600 degrees is more than 1 full circle, so if I take off 360, I'm going to get 240 degrees, and this is just a coterminal angle, so I can just deal with the coterminal angle. 240 degrees puts me there in the third quadrant. So I need to consider the reference angle back to the x-axis. This reference angle right here. So the distance between the x-axis and there, if this is 180, and this is 240, then the distance there is a 60 degree reference angle. So I need to consider my 30, 60, 90. So this would be 60 degrees with side lengths 1, 2, square root of 3. Cotangent is the inverse of, or the reciprocal rather, of tangent. Tangent is opposite over adjacent, so this one would be adjacent over opposite. So the cotangent of 60 degrees would be adjacent over opposite. And then we consider, since we're using a reference angle, we always consider what quadrant we're in. We're in quadrant 3. And in quadrant 3, tangent and cotangent stay positive. So this answer here is going to stay positive. So the cotangent of 600 degrees is 1 over the square root of 3. And if you're used to not having radicals in the denominator, you can write that as the square root of 3 over 3. Question 17, I'm going to go ahead and take that out of radians into degrees. 6 goes into 180 30 times. 5 times 30, 150, so this is 150 degrees. So I'm going to consider the cosecant of 150 degrees. That's 150 degrees, leaving me a reference angle there of 30 degrees. So I need the 30, 60, 90, 30 degrees here. Now, 30 degrees and cosecant. The definition of cosecant is the reciprocal of sine. Sine is opposite over hypotenuse, so this would be hypotenuse over opposite. So hypotenuse over opposite. So the cosecant of 30 degrees would be 2 over 1. And then we consider quadrant 2. The sine and the cosecant stay positive, so our answer is going to stay positive. So the cosecant of 5 pi over 6, or the cosecant of 150 degrees, is equal to 2, positive 2. And finally, question 18. Three goes 180 60 times, so it's negative 120 degrees. Remember, negative angle measures go clockwise. So this is negative 120 degrees. The reference angle would be drawn to the x-axis there. So if we have 180 and negative 120, negative 120 is the same thing as positive 240. So this would be a distance there of 60 degrees. So the reference angle there is 60. So we need the 30, 60, 90. Secant of negative 120. And rather than using negative 120, I'm going to do 240, because 240 and negative 120 are the same. Is going to be, I'm going to change that to the secant of its reference angle, which is 60. So the secant of 60, secant is the reciprocal of cosine, and definition of cosine is adjacent over hypotenuse, so the reciprocal of that would be 2 over 1. And since we're in the third quadrant, the only two trig functions that are positive in the third quadrant are tangent and cotangent, so that means secant is going to become negative in the third quadrant. So the answer here is going to be negative 2. Okay, 19. We have a couple of values to find here. 225, 240, and 60. So start with 225. That's right there. 240. It's right there. So it's 225, 240. 60 degrees, we don't need a reference angle with that one. So 225, the reference angle right there is going to be 45 degrees. So I'm going to consider tangent of 45 for that one. Now 240, the reference angle there would be 60. So I'm going to consider the sine of 60. So for 45, 90 triangle is 1, 1 is square root of 2. Tangent is opposite over adjacent. So tangent of 45 equals 1. And since we're in quadrant 3 and tangent stays positive, it's going to stay positive 1. So this is 1. Now, sine of 60 is opposite over hypotenuse. So the sine of 60 is square root of 3 over 2. And since we're in quadrant 3 and only tangent and cotangent are positive, this has got to become negative square root of 3 over 2. And then cosine of 60, if I want to use the same triangle here, cosine of 60 is adjacent over hypotenuse. So that's 1 positive 1/2. So the expression I need to consider is 1 plus negative root 3 over 2 times 1/2. So this is 1 minus square root of 3 over 4, which is 4 over 4 minus the square root of 3 over 4, or 4 minus the square root of 3 over 4. Now all of these are radian measure, so I'd recommend that we convert all of these into degrees. So for this one, 4 goes into 180 45 times. So we need 7 times 45. That's 315. And then 3 goes on 180 60 times. And 60 times 4 is 240. 6 goes on 180 3 times. 7 times 30 times rather. 7 times 30 is 210. So this is 315, 240, and 210. So for the first one, 315 degrees is right there. The reference angle there would be 45 degrees. So I need 45, 45, 90. And then cosine is adjacent over hypotenuse. So the cosine of 45 is 1 over the square root of 2. And since we're in quadrant 4 for that one, in quadrant 4, cosine stays positive. So that one's going to stay positive 1 over the square root of 2. Now, for the second one, 240 is right there. The reference angle is that gap between the x-axis. So the difference between 180 and 240 is 60 degrees. So I need my 30, 60, 90 triangle, which is 1, 2, and square root of 3. and tangent is opposite over adjacent. So tangent of 60 is square root of 3 over 1. And since we're in quadrant 3 for that particular angle and tangent is positive in quadrant 3, this one's also going to stay positive. So far our computation is, for the first expression, 1 over square root of 2 multiplied by square root of 3 over 1. I just got to figure out what that last one is. Cosine of 210 210 is right there. The difference to the x-axis between 180 and 210 is 30 degrees. So we need the cosine of 30 degrees. I can use this triangle here that we already have, and 30 degrees would be up in this corner. And the adjacent length would be square root of 3, and the hypotenuse would be 2. So cosine of 30 is square root of 3 over 2. But since we're in quadrant 3 here, and only the tangent and cotangent are positive in quadrant 3, this one's got to be negative. So it's negative square root of 3 over 2. So this one here, even though technically 1 over the square root of 2, it's okay to have a square root in the denominator. It's going to make this computation a little easier if you rationalize that and make it square root of 2 over 2. So now, these two here, square root of 2 times the square root of 3 is the square root of 6 over 2 plus negative square root of 3 over 2. So we have square root of 6 minus square root of 3 all over 2 for question 20. Okay, question 21 and 22, these are from section 2.4, using trig identities to write the expression in terms of a single trigonometric function or as a constant. So we had a couple of identities that we talked about in section 2.4, the ratio identities, reciprocal identities, and the Pythagorean identity. Okay, so one of the identities for secant is that it's the reciprocal of cosine. And then one of the identities for tangent was that tangent is equal to sine over cosine. And then dividing by a fraction means dividing or multiplying by the reciprocal. And then cosine cancels, so we have 1 over sine t. For question 22, one thing we can consider is to separate this into two separate fractions. Since it has only a single term denominator, we can write this as two fractions, tangent of t over tangent of t plus cotangent of t over tangent t. And then obviously that can simplify to 1. And then instead of writing it as cotangent of t divided by tangent of t, I'm going to write it as cotangent of t multiplied by 1 over the tangent of t. And then remember that the 1 over the tangent of t, the reciprocal of that would be another cotangent and then cotangent times cotangent is cotangent squared. Now, one thing, couple of things it says to do here, amplitude and period. So I'm going to start with that. Amplitude for question 23 is 3, and then period is 2 pi divided by the absolute value of b there, which is 2. So one full cycle is going to come all the way out here to pi. And then break that up, and it's already nicely labeled for us. So sine function starts at the midline, and then up to its highest point, back down to midline, down to its lowest point. And since the period is pi, one cycle is going to end there. For question 24 rather, the cosecant is very much related to sine. So period is 2 pi divided by the coefficient here, which is 1/2. And that's equal to 4 pi. So one full cycle is going to come all the way out here to 4 pi. And what was discussed in class is to graph cosecant, you would first consider what a sine function looked like. And a sine function would have an amplitude of 2. So the sine starts at the midpoint and then comes up to positive 2, back down to the midpoint, down to negative 2. So the sine function graph would look like that. And then anytime that graph crosses the x-axis, you would have a vertical asymptote. And then the highest point there becomes the lowest point of that portion of the cosecant graph, and then the lowest portion here becomes the highest part of that piece of the graph. Now, tangent has a period that's only pi units. So pi divided by b, in this case b is 1/2, is equal to 2 pi. So the distance between vertical asymptotes has got to be 2 pi. So I place one here at pi, and then this would be negative pi halves, and over here would be negative pi. So if I have another vertical asymptote here at negative pi, or if you wanted to span a distance here from pi to 3 pi, that'd be the same distance or the same period of 2 pi. So you could also place a vertical asymptote there. And if you remember, the tangent graph looks like that. Now for secant, period is 2 pi over b. So one cycle is going to end there at pi. And secant graph is related to a cosine graph. And this cosine graph would have an amplitude of 2. And cosine, remember, starts at the top of its amplitude, comes down to the midline, bottom of the amplitude, back up to midline, and then ends at the top. So the cosine graph, which I'm going to do dotted line there, would look like that. Anytime the cosine graph there crosses the x-axis, that's where you would place your vertical asymptote. And then high point there, the graph flips upside down, high graph, or high point, flips upside down, and then this low point, the graph flips upside down. Okay, for 27, cotangent, same as the tangent, has a period of pi divided by b. And if you recall, the cotangent has a vertical asymptote, starts at 0. And the period is pi halves, so we're going to have another one at pi halves. And then at pi, then at 3 pi halves. All of those have a horizontal distance of pi halves, and that's where you place your vertical asymptotes. And the shape of the cotangent graph looks like this. For 28, 2 cosine of pi over 2, period, is 2 pi divided by b, which is 1/2, so 4 pi. Amplitude would be 2, so one cycle there is going to end at 4 pi and go up to 2 and down to -2. Now the cosine, remember, starts at the top of its amplitude, and then since it ends here at 4 pi, it's going to come up there to the top, back up to the top of its amplitude. Now for 29, this was from section 2.7. Now we have phase shift and also a vertical translation there. So first thing, let's talk about amplitude. Amplitude is 2. Period is 2 pi divided by b, which is 1/2. It's 4 pi. And then the phase shift is the opposite of c over b. So the opposite of c, if this is c right here, would be negative pi thirds, and if we divide that by b, then we're going to get negative 2 pi over 3. Another way you can do that is by considering this expression here. If you factored out the 1/2, you'd have theta plus 2 pi over 3. So now 2 pi over 3 becomes your horizontal shift to the left, if you want to think about it that way. Or, since this is negative 2 pi over 3, it moves to the left, negative 2 pi over 3 units. So, and then it moves down 2 units. It's got a vertical shift down 2 units. So I'm actually going to not use the given graph. I'm going to make my own. I know it's going to shift down 2 units. And then it's going to go left negative 2 pi over 3 units. So if I have pi halves, pi, negative pi halves, negative pi, then negative 2 pi over 3 is going to be somewhere right around here to the left. And then it's got to shift down 2 units. So then that would place right about there. So this point that I've just plotted is roughly negative 2 pi over 3 and down 2 units. So the technique described in section 2.7 is to consider a shift of axes. So rather than the origin at 0, 0, you can consider a new set of axes with the point negative 2 pi over 3, comma negative 2 as the origin. And then you would graph from this new set of axes, you would simply graph the function y equals 2 sine of theta over 2 with no translations. So on this one you could graph y equals 2 sine theta over 2. So the period there would still be 4 pi. So if I start here at the origin and come out a distance, the full distance from there to there needs to be 4 pi. And I do have to correctly label my endpoint. That's what we talked about in class. So if I want the total distance to be 4 pi, but I'm already starting at negative 2 pi over 3, then I need to subtract those two, 4 pi minus 2 pi over 3. And 4 pi can be 12 pi over 3. So 12 pi over 3 minus 2 pi over 3 is 10 pi over 3. So the point on the x-axis that would reach that period is 10 pi over 3. And you split that into fourths. And the sine function starts at the origin, and since the period is 2, it's going to go up 2 units to 0, then back down to the midline, and then down 2 units to negative 4, and back up to the midline. So it would look like that. Okay, for question 30, period is 2 pi over 2, which is pi, and then the phase shift is negative c over b, so that's negative pi 6 divided by 2. And divided by 2 is the same as multiplying by 1/2, so this is negative pi 12ths. So that means it's moving to the left. Well, actually, this should be positive, because the opposite of c would be positive pi over 6, so this is positive pi 12ths. So it's moving to the right pi 12ths of a unit. And then there's also a vertical transformation here, so it's going to shift up 1 unit. So I'm actually going to use the graph provided. So this would be pi 4ths of a unit right there. So pi 12ths to the right would be very close there to the origin, and then it's going to shift up 1 unit. So I'm going to consider a new set of axes right about there. That axis has been shifted to the right, pi 12ths of a unit, and up 1 unit. Now, the amplitude, if there was amplitude, secant doesn't have an amplitude, but cosine does. The amplitude would be 1. So I know it's going to go up 1 unit to 2 and down 1 unit to 0. And the period was pi. And since I started just barely to the right of 0, and if I'm going to go over pi units, I'm going to end just barely to the right of pi. So that's going to be the exact coordinate location of that is pi plus pi 12ths. So if this is 12 pi over 12 plus 1 pi over 12, then the ending point there is 13 pi over 12. And remember, as we discussed in class, all I want you to label is where it begins, which is pi 12ths, and where it ends, which is 13 pi 12ths. And then just mark the axes into 4. Cosine starts at the top of the amplitude, which would be 1, down to the midline, to the bottom of the amplitude, back up to the midline, and ends at the top. Now I'm going to do this on a dotted line, because remember, we're not graphing cosine, we're graphing secant. And then wherever that crosses, you're going to have a vertical asymptote. So here and here. And then for secant, you turn the graphs up.